Oh, hi there. I didn't see you come in. Welcome to the Scientific Adventures of Beardman. Today we're going to take a look at net force. We learned recently that an object will maintain its constant velocity if there is no net external force. And we said we'd learn later what net force is. Well, today is that day. Some of you may be familiar with the term net from a different context, so I want to start by looking at that. If you've got a job and you've ever gotten a paycheck, you may have noticed that the line at the bottom that you care about, which is the amount of money going in your bank account, is your net pay. Well, what is net pay? Net pay means that you've got your gross pay, your $10 an hour times 40 hours you worked or whatever, $400. But then some of that gets taken out for federal taxes, some gets taken out for state taxes, some for Social Security, and by the time you're left and you get your $4, that's your net pay. In other words, it's the pay after you've taken everything into account. Well, net force is very similar. You may have a force that you look at and think about, but then there are other forces acting on an object, and after you've taken them all into account, how much force is left over? Well, a couple things. First of all, you want to be sure as you're trying to figure out the net force that you only take into account forces that are on the object. Forces the object puts on something else aren't the forces on the object. So only count the forces on the object in order to determine the net force on that object. If you have two forces on an object that are in the same direction, like your tractor breaks down and you get behind it to push, and your father-in-law gets behind it to push, and you both start pushing, well then you take the force from one of you plus the force from the other because it's in the same direction to get the net force, which is the two added together. On the other hand, if you are pushing one way on the tractor and somebody else runs around the other side and pushes against you, well then when the forces are in opposite directions, you'll need to subtract the forces in order to find the net force. This happens most commonly with friction, because there's often a force that's trying to get the object to kind of keep moving, whereas friction is always opposing the motion. So if you ever have a situation where there's a frictional force and the object is not accelerating, it's moving along at a constant speed, well, keep in mind, if there's a constant speed, that means the acceleration is zero, which means the net force is zero, and therefore the force that you're applying must be equal to the frictional force. And then when you subtract them, you get zero. And so thanks for tuning in on Scientific Adventures of Beardman. I look forward to learning with you next time.